Hello students and welcome again. Now in this example we're going to be checking getting roots without given any particular root. So you're supposed to get all the four roots from the beginning up to the end. So my name is Mr. Meshak Ngige. Kindly remember to subscribe, share and also comment how these lessons are being helpful to you. Now let us jump right in. Now solution. Now this question, first of all, from the equation itself, how many solutions do we need? How many? We need 4 because the highest power is what? The highest power is 4. Now I'm going to teach you two different methods of doing this. So we'll start with what you know. That is the basic, all right? So we have this. Now let's start with what you know first. We know by De Moivre's theorem that if you have r theta raised to power n, this gives us what? It gives us r raised to power n, right? Then you have what? N, we have n theta. And again, remember this is just a short form of the polar form, because in actual sense, polar form, we have r cos theta plus j r sin theta. Now if we say again this is to power n, then we are saying this one is r. We can put our rn outside. Then we now take the part inside. So again, remember this power multiplies the angle, so we shall have n what? N theta plus j sine of what? Sine of n theta. So this and this just represents the same thing, and together just the same thing. Now remember, the value of n does not really mean it has to be a whole number. It is true for every positive, negative, fractional indices, right, together. So that is to say, if I have again r theta and I have a root 1 over n is a root, right, together. This one is a power, this one is represents the root. Again, this is just the same, r 1 over n, then 1 over n what? 1 over n theta. So whichever number that you have here powers the r, multiplies the angle that you have there. So that is it. Now, so in this solution, in method number 1, we're going to solve, I've said we're going to have two methods of solving this. So method number 1, what you do here is you change this into polar, get the roots the long way. I can call it the long way. Then after getting the roots in polar form, then return them back in what? In Cartesian form. Are we together? So you change the first into polar, get the roots, then return them back to Cartesian form. Now in our equation here, so we have z to power 4 plus, so now let's take everything else that does not have a z on the other side. So we shall have negative 8 root of 3 minus 8 what? Minus 8j, because this is positive, so it goes to the other side, becomes what? It becomes a negative. Now, so therefore, for us to get the value of z, we shall have to get the root. So 3 minus 8j, then into bracket, we get the what? 1 over 4. So we get the fourth root on this side and also the fourth root on this side. So our value of z will be given by this solution. All together. So therefore, how do we find the root again? We change our Cartesian form here into polar form, and what do we need to get? We need to get two things. We need to get our r, which is given by x squared plus y squared, then the square root, that is the first. Then we also need to get our theta, which is given by tan inverse of y over what? Y over x. Right? Now, but there's something important again. We always say when you are working with complex numbers, it is always good for you to sketch your variables in the Gantt diagram. Now let's sketch this part here. So from just what you know from Cartesian, this is the real part. Now in terms of complex number, the image, the imaginary of z. So we don't call them x and y, we call them the real and the imaginary. Now our values is negative and negative. So in the Cartesian plane, where do we have a negative and a negative? So we shall have a negative on the real side. So I can say this one is my negative 8. Then negative on the y. So do I go upwards or downwards? So I'll have to go downwards. So therefore, your point z, your z point here will be on the on the third quadrant. That's very important because your actual angle should lie. Your first angle that you're going to get should in one or the other lie here, right together. So that is very important. So it is always important for you to sketch so that you know where your value lies. Now, knowing this, now let us get our R. So our R, therefore, our R, okay, so our R will be given by, so our X value and our Y value. So this is negative 8 root of 3 squared plus negative of 8 squared, then the square root. So what does that give you? So you can calculate that in a minute. So you're going to get the root of 256, and the root of 256 is what? Is 16 degrees. Is 16. That is a scalar quantity. Now we come to theta, which is given by tan inverse of negative 8. That is on the y-axis. Then x is negative 8 root 3. Now this and this can cancel, this and that can cancel. So you just remain with tan inverse of 1 over the root of 3. And this is simple if you know the diagram, which gives us the ratios of angles, especially then the angles that is 30, 60 and 45 degrees. So basically this is just a 30 degrees angle. You can verify that. So your angle is 30 degrees. But now the question remains, is this the true angle? Is this the true angle which is supposed to get? Remember we said the necessity of drawing this is to enable you to know where the angle lies. And you have seen the angle is not here, it is not here, it is in the third quadrant. How do we get the angles in the third quadrant? It will be 180 plus theta. Alright? So if we have our theta being 30 degrees, therefore it means we'll have to add 180. So your value for theta will be 180 plus 30 degrees, which gives us that is 210. That should be 210 degrees. So it is very important so that you don't be tempted to use 30 degrees because it will be wrong. It belongs in the first quadrant, but we want in the fourth. So now we have our R and we have our theta. So therefore your Z, now rewriting them in polar, will be 16, then 210. Okay. So 210 degrees, then 1 over 4. I've just rewritten this form. Okay, I've changed now whatever is inside to be in terms of polar. So therefore your Z will be given by 16 to power quarter, then we have a quarter here, then multiply by 210 by De Moivre's theorem. And what is the fourth root of 16? That will be 2. When you divide 210 by 4, that is 2.5. So 52, you have 52.5. Now this is your value of Z1. Alright, this is your value of Z1. Now something else that you need to know when you are solving roots. We say that roots are always 360 degrees over n symmetrically spaced. So we'll have this, so we'll have 360 where your n is your root. Right, together, n is your root. So what are we getting? We're getting the fourth root. If you're getting the cube root, divide by 3. But in our case, we are getting fourth root. So therefore, we shall have 360 degrees divided by what? Divided by 4, and that should be 90 degrees. So this angle will repeat itself again. The next root will occur after 90 degrees. Right, together. The value of R remains because if I have a length here, regardless on which quadrant I take, my length will be the same. It will not change. Are we together? So my R will remain constant, by the angle is the one which will change. So if there are 360 over n space, which in my case gives me 90, then I'll add 90 here for me to get Z2. So Z2 will be 52 plus 90, that gives me 142, 142.5. Then Z3 will give me 2. I add 90, that is 230. 2.5. Z4, I add 90 here, gives me 322.5. Now these are your 4 roots in terms of what? In terms of polar form. But remember, you're supposed to give your answers in terms of what? In terms of Cartesian form. So now change all these into Cartesian form. So you can do the first one, then you'll do the other 3. So how do you write complex numbers in Cartesian? So in Cartesian form, your z is given by x plus yj, that is in Cartesian. But now your x in polar, how do you get your x? X is given by r cos theta. How do you get your y? It's given by r sine theta. So you can basically have your j outside, whichever side. So you have your r. For example, in the first one, you have your r, you have your theta. So you can just replace that so that you get that one value. Then you try all the others. So I'll grab only this part. So therefore, we are saying, so your first value, so z, your r is 2, cosine of our first angle is 52.5 plus j, and I have my j outside. Then I have r sine theta. My r is 2, then sine again is 52.5. All right. So therefore, what do we get here? 2 cosine of 52.5 gives me 1.2175 for decimal places. Then I have j, then 2 sine 52.5 will give me 1.5867 in Cartesian form. So basically, this is your Z1 in Cartesian form. So your Z2, for the sake of writing, it is 2 cosine of, what is your now second angle? 142.5 plus j, then 2 again sine of 142.5. Get your value. Z3 be given by 2 cosine of, what is our angle? 232.5 plus j, 2 sine 232.5. Then the last one, Z4 be given by 2 cosine of 322.5 plus j, 2 sine 322.5, and that will give you all the form. So we have the polar form and we'll have the Cartesian form. And remember, sometimes in Knec exams you'll be asked to give your answer in the form of A plus JB or BJ. This means Cartesian form. Are you together? Yes. So you don't leave it in polar. So that is from what we know. That is from what we have handled before. Now we want to see in what best way can we handle this so that we can have just our angle directly from instead of changing from polar, then from polar, then we go to Cartesian. How can we work it directly? And that brings us to the second method. And before we check the second method, we'll say now, if we are talking about angles being spaced 360 degrees over n, what is 360 over n? In terms of radians, this is the same as 2 pi over what? Over n. So our angles can either be given in terms of pi, which is the radians, or it can be given in terms of degrees. All right. Now let's check the second method of how to solve such an equation. All right. Let's now check the second method of how to solve this. So method 2, which I believe is simpler. Now, so one thing again to remind ourselves is r theta. Now since we are finding root, let's define it in terms of roots. It will be r1 over n, then we have theta 1 over n, 1 over n theta. All right, so we have that. Now, so the root now, if I write it now in terms of the trigonometric ratios, we'll have for just say, let me just define it. Just say for distinct for distinct roots, we shall have this just be given by the root of n, so r1 over n, right? Then cos of alpha plus j sine of alpha. Where now this alpha, we shall define it by this, so alpha will be given by the angle theta that you get, then 2 pi, then we shall add a k. Remember, we are saying that our values will always be repeated again and again after 2 pi, all right? But now, since the rotation might not happen once, when our value of k basically changes, we'll have a k, a variable k added there, then all of that divided by n, where k values, you can say these values will be 0, 1, 2, depending up to the root, that should be n minus 1, so up to n minus 1, where this one is in terms of radians, right, together. So we can also write it in terms of degrees. Actually, you can say again theta plus 2 pi is the same as 360 degrees, k, then all of that over n, right? So we can have that, where again k value is given by 0, 1, 2, up to n minus 1, where this one now in terms of degrees. So you can choose both ways. You can choose it to work in terms of radians, or you can choose to work them in terms of degrees, right, together. So our n value is the root, all right? So let's now solve our equation, and you see how interesting that becomes. So, but by the end of the day, what you need to get, one, you must get the r and you must get the theta. You must get these two values by the end of the day. So if you're using 2 pi, you'll have to write your value theta in terms of what? In terms of radians. You can say where your theta here is in terms of rad, where this one represents radians, and your theta here is in terms of degrees. So kindly don't confuse. If you're working with degrees, work with degrees all through. If you're working with radians, work with radians all through. So now, since we had already worked our values for r and theta, we don't need to write them again. So our r in this case was given by 16, and our theta was given by 210 degrees. Remember, it was not 30. We got 30, then we got the actual value for theta, which gave us 210. Now, so we now start, we determine our z1. So we can say when k is 0, we have said that our values of k will start from 0, and our n is constant. N will be 4 all through for all the values. So our k is 0, n is 4. Now we replace them here. So let's say we are now getting what? Z1. So we're getting Z1. So our r will be r to power 1 over 4. So it is 16 to 1 over 4. Then into bracket cos. Now this part, so we replace it by the whole of this. So our theta is 210. So because we are working with the degrees, all right? So we use this. So theta is 210 plus 360 multiplied by 0. Then that over n. Then plus, put our j outside. J. Then we come to sine. Then 210 plus 360. Our k is 0. Then we have 4. So we have our 4 here. So we can have our first value. So this one to power quarter gives us 2 into bracket cosine of. These are 210. This multiplied by 0 is 0. Then divide by 4. So it is 210 divided by 4, which gives us 52.5 plus j sine of 52.5. And what did we get? You can remember this. Remember, this 2 is all it is under all these. Let me rub this and rub this, and I have this and that. So the 2 opens up everything. So we have 2 cosine of 52.5 plus 2j. Remember, we have a 2, then sine. Sine of 52.5. And what did we get? We got the same values. So I think it was 1 point something. So this one was 1.58. It was j 1.58. 0.867. For the first one, 2 cosine of 52.5. You get what? 1.2175. And you can see this one has taken you directly up to the what? It has taken you up to the Cartesian. So you have not changed into polar first, you have gone directly and solved up to the Cartesian. Now let's check for Z2. Z2 again. Now our Z2 will be given by, so let me start by this statement. When now our K was 0, now you go to K equals to what? 1. Our N is still 4, so our N does not change. Again, our Z2 equals to 16 again to power quarter, because it is R to power quarter from that statement there. Then we have the cosine of, now this value here, it is 210 plus 360 times 1, because our K is 1, right? This K here is 1. So 360 times 1 is 360. Then you divide by what? Divide by 4. Then plus J sine of 210 again plus 360, then all over 4. These values are always the same. And then you have the outer bracket. So this one again is 2, then into bracket cosine of. So 210 plus 360 plus 360. Okay, that gives you 570, correct? Then you divide by 4. It gives you 142.5. 142.5. Then plus J, then the sine. So the angle, whatever you've gotten here, will be the same here. All right, sine of 142.5. Now again, the 2 opens up the bracket, becomes 2 cosine of 142.5 plus J 2 sine of 142.5. So 2 cos 142.5, sorry, 142.5 will give me negative 1.5867. Then 2 sine of 142.5 will give me 1.2. So plus 1. So you can start with the J. You can have the J, then 1.21752. So you have that basically. So the first value, this is Z2. Z3 again, now you take your, so your Z3, now you go again the next step when K equals to 2 and N equals to 4. You'll get your Z3. Then the last one when your K equals to 3 and your N equals to 4, and you'll get your 4 solutions for this. Anyway, let's just complete it and have it. So when your K is 2, so we'll have okay. So when your K equals to 2, N equals to 4, so we shall have our Z3. Our Z3 will be given by, again, 16 to power quarter. Then you have cosine of, so we have 210 plus, what is 360 times 2? Because our K is 2 now in this case, so it is 720, then all over 4, then plus J, all right, we have a J there. Then we have sine of the same term, 210 plus 720 over 4, then of this bracket, yeah. So this is the bigger bracket outside here. So we have that. Now 210 plus 720 gives us 930, right? Then you divide by 4, gives me 232.5. So therefore our Z3 will be given by that one is 2 again into bracket cosine of 232.5. Okay, yes, 232.5, then plus j sine 232.5, which gives me 2 cosine of 232.5 plus j 2 sine of 232.5. You have that. So 2, the cos of that angle, 2 cos of 232.5. Hope that is correct. I'll have negative 1.217.5, then 2 sine 232.5. I'll get negative of 1.5867j. I can have minus j there. So that is my Z3. Then lastly Z4. I'll have again, that is when my k, let me just have here. So when my k equals to, that was 2, so 3, and n equals to 4. So again I'll have my Z4, which will give me 16 to power quarter, then into bracket cosine of 210 plus, we have 360 times 3, which gives me what, 1080, then divide by 4. So I have that plus j sine of 210 plus 1080, then over 4, then the bracket outside there. So we shall have what, 2, then we have the cosine of, so plus 210 gives me that, then divide by 4 gives me 322.5. So if this value then is the same, j sine of 322.5. Right, and that will give me what? So 2 cosine of 322.5 will give me 1.5867 plus j. So we have a j. Let me first of all check what we have there. Sine 2. Yeah, because the 2 will open up everything. So I've just calculated 2 times this, 2 times that. So I'll have 2 sine of 322.5 will give me negative of 1.2175. There's a j there. And those are the 4 values for getting the values. So that is it. So you can see now this one takes you directly when you're working with what? When you're working with that particular formula.